Greetings. We've got this wonderful question falling under transformers. So if you're in Zambia, this came in 2020 for GCE candidate science paper 1. So if you look at this particular question, the way the question is, a setup transformer increases the voltage of an AC supply from 110 volts to 220 volts. So this is now telling you to say that for sure it is a step up. What do I mean when I say a step up? A step up transformer increases the voltage. Have you seen? It is how many? It is 110. It has now increased to 220. So a step up increases the voltage of a transformer. The primary coil dispatches a power of 1.1 kilowatts, and the transformer has an efficiency of 100%. So these are the questions that I want to make simple. So we can answer this particular question without even putting a free body transformer here, like putting a transformer here. No, we can answer this question without doing that. So the first question is telling us to say, if the number of turns in the primary coil is what? In the primary coil is what? 400. How many turns are in the secondary coil? To answer this particular question, you need to know which formula am I going to use. This is the first thing you need to ask yourself. So if you are given voltage and you are told to find the number of turns, have you seen here? They are telling us to find the number of turns. So we've got the turns that are in the primary. Now I want to find the ones that are in the secondary. So the formula we need to use, we get to say that voltage in the secondary over voltage in the primary. So which is equal to the number of turns in the secondary over number of turns in the primary. This is a particular formula that you need to get. So V is voltage in secondary over voltage in primary. So number of turns in secondary over number of turns in primary. This is a formula. Then you just get the information that is given and substitute in this particular formula. So what is voltage in secondary? This is the voltage in secondary, which is what? 220. So I'll say 220. Let me write it here so that it gets to be uniform like that. So let me write it here. So I'll say 220. That is the voltage. 220 over. What is the voltage in primary? 110. How did I know? I've already told you. It is increasing from 110 to 120. So where it is starting from, that is the primary to secondary. So this is what is happening, which is equal to the number of turns in secondary. We don't know. That is what we want. So we can put X there over. Then the number of turns in the primary coil, we are given 400. So I need to put my 400 there. I guess you people are able to see. This is so simple and I don't need anyone to be confused when doing this. Straight away, we say X times 110. So we are going to have 110X, which is equal to, what is 220 times 400? You are going to get what? You are going to get 88,000. So we get 88,000, where we are going to divide both sides by 110. So 110, even there we divide by 110 because we want to find X. So therefore, X is equal to, we divide by 110. So we get to divide by 110. What is the answer? We get what? 800. So we've got 800 what? 800 tons. So we get to have 800 what? 800 tons. So this is it, and this is how you need to go about it. We are done. So you can now conclude and say that therefore the number of tons in the primary coil is 800. So you are done. Conclusion, very important. Even as you get to answer these questions in an exam, the marker should know that for sure this candidate knows what he is talking about. So we are done with the first one. We've calculated the number of turns. So this is the formula you need to get. Whenever we are answering those questions, this is the formula we get to use. Votes over what? Votes secondary, votes primary. Number of turns secondary, number of turns primary. As simple as that. Let us proceed now to the next question. The next question here is saying, how many current flows in the what? Primary coil, secondary coil. So want to find the number of what? Here it was supposed to be how much. So it is supposed to be how much current. So how much current flows in the what? Flows in the primary coil. So in the what? Primary coil. So I want to find the primary coil. If you look at this question the way it is, we are told to say that the primary coil dispatches a power of what? We are given this power that is there. What is the power? This is the power, which is 1.1 kilowatts. So to find now the current, you know that power is equal to voltage over current. So we are looking for this current. Voltage we know that is in the primary. It is that one. Then we know the power, it is 1.1 kilowatts. Now it is in kilowatts. For us to convert from kilowatts to just watts, this calculate that they have put kilowatts, you know that they had to divide by 1,000. So to make it return to its former normal way, we need to multiply by 1,000. So 1.1 times 1,000. What answer we get in there? We are going to get 1,100 watts. So meaning that this is the power. So we substitute there. Power is what? 1. This is the power, which is equal to what is the volts? Volts in the primary, that is what? 110. So 110 what? 110, I'll say 110 times I, which is the current that we are looking for. So from here, what are we going to do? We just divide both sides by what? Both sides by 110. So over 110 there, even here over 110. So then this one will be cancelled. So current is now equal to this will be cancelled. So now if you get to divide 110, so we are having 110 divide 11. What is the answer? The answer is 10. So therefore we've got 10 what? 10 amps as the current in the what? In the primary coil. This is how you need to answer it. We proceed now. We go to this next question that is here. Secondary. So there's nothing being said there about secondary if you analyze the question. So what we are going to use, there is a formula that states that power in the primary is equal to power in the what? Secondary. There is something like this. So this is the formula we are going to use. Then you know the formula for power is this one. So now power in the primary is already given in the question. So what is the power in the primary? We've calculated and this is it. This is 1,100, which is equal to. Then power in the secondary, power is equal to volts times current. Why am I doing this? Because I want to find this what? This current. The voltage I know, isn't it? The voltage I know. What is the voltage? If you check the question, the voltage is already there. So what is the voltage? The voltage is what? The voltage is 220 there. The voltage is 220. So I now substitute in that. What am I going to do now? So even as I proceed, those of you that are interested in starting your tuitions with me, this is my number. WhatsApp me on this particular number. I'm going to help you with your tuitions. So this is my number. So this is my number. You WhatsApp me on this number. I'm here to help you get that distinction that you want in an easy way. So I will say 1,100. Finish this question. Let me see answers in the comment section. What is voltage? Voltage is 220 times I, like that. I divide both sides by what? I'm going to divide both sides by this one that is here. So I divide by 220. Let me see answers now. What is the current? 220. Even there, I divide by 220. So this cancelled. So current is now equal to, I now get to divide now. What is the current now in the secondary? What is the current? So what I'm going to do, I'm saying 1,000. So 1,000 what? I'm saying 1,100 divide by 220. What answer we getting? If we divide, we are getting 5. So the answer is 5 amps. Just like this. So this is it. This is what you need to do. So like this, we've answered this particular question. Those of you that are interested in starting your tuitions with me, this is the number. And don't forget to support us. What I mean by supporting, liking, commenting, sharing, and following. Don't forget to follow us. Don't forget to like, comment, and share this particular video. So these are the solutions. I guess you've seen how I've answered this question. So this is how you need to go about questions. I'm yet to do a lot of questions under transformers so that I can help you and prepare you for your exams. Thank you so much. Lessons get to be done at an affordable fee via WhatsApp. I've got a group on WhatsApp, so you can text me here. I will explain to you what you want to know about our online lessons. They get to be done at an affordable fee. Thank you so much.